In the shadows of military aviation, history lies a machine so extraordinary that it defies everything we thought we knew about flight. Picture this: an aircraft weighing over 100 tons that can slip through enemy airspace completely undetected. A bomber so advanced that radar operators would swear their screens had malfunctioned when it passed overhead. At a staggering $2 billion per unit, this flying marvel represents the pinnacle of aerospace engineering achievement. What makes an aircraft invisible to the most sophisticated detection systems on Earth? How do you take something the size of a football field and make it disappear from radar screens? Today, we're peeling back the classified layers of one of the most secretive projects in aviation history, the B-2 Spirit stealth bomber. The story begins during the height of Cold War tensions in the mid-1970s. American military planners faced a terrifying reality. Soviet air defenses had evolved into an impenetrable wall of missiles and radar systems. The massive B-52 bombers that formed the backbone of America's nuclear deterrent had become sitting ducks. These flying fortresses, once the ultimate symbols of air power, would be obliterated before they could reach their targets. Military strategists knew they needed something revolutionary. Not just a faster bomber or a higher flying one, but something that could rewrite the fundamental rules of aerial warfare. The solution would require breakthrough technologies that pushed the boundaries of physics, materials, science, and computer engineering. But here's where the story takes a fascinating twist. The revolutionary design that would eventually become the B-2 had actually been conceived decades earlier by a visionary aircraft designer named Jack Northrop. Back in the 1940s, Northrop had created the flying wing concept, an aircraft that was essentially one continuous wing with no traditional fuselage or tail section. His early prototypes, including the experimental YB-49, flew in the late 1940s, but were ultimately deemed too unstable for military use. The Air Force ordered every single prototype destroyed, crushing Northrop's dreams and seemingly ending the flying wing concept forever. Yet sometimes the most groundbreaking ideas simply arrive before their time. When the Air Force launched its Advanced Technology Bomber program in the late 1970s, they were searching for a design that could achieve the impossible: true stealth capability. The flying wing configuration suddenly made perfect sense. The B-2's distinctive triangular shape isn't just aesthetically striking, it's a masterpiece of radar deflection engineering. Every angle, every curve, every surface has been meticulously calculated to scatter radar waves away from their source. But the real magic happens at the molecular level, where specialized coatings absorb electromagnetic energy like a technological sponge. This isn't just about avoiding detection, though. The engineering challenges of creating a stable, controllable flying wing required innovations that wouldn't be possible without cutting-edge computer systems, making thousands of adjustments per second. The control systems governing the B-2 represent perhaps the most sophisticated flight management technology ever deployed. Without a traditional tail to provide stability, this massive aircraft relies entirely on what engineers call fly-by-wire technology. Every millisecond, onboard computers process thousands of data points from sensors scattered throughout the airframe, making instantaneous adjustments to keep this flying wing from tumbling out of the sky. Think about that for a moment. You're piloting an aircraft that's fundamentally unstable by design, yet these computer systems make it feel as smooth as driving down a highway. The processing power required is staggering, with over 130 separate computers working in perfect harmony to maintain flight stability. But stability is just the beginning. The B-2's engines present their own engineering marvel. 4 massive turbofan engines are buried deep within the wing structure, their air intakes cleverly positioned on the upper surface where they're invisible to ground-based radar. The exhaust system has been designed to spread and cool the hot gases, dramatically reducing the aircraft's heat signature. This attention to thermal management extends throughout the entire design. Engineers realized that even the slightest heat buildup could betray the bomber's position to infrared sensors. Every component that generates heat has been carefully shielded and cooled, creating an aircraft that's as invisible to heat-seeking missiles as it is to radar. The materials science behind the B2 reads like something from a science fiction novel. The primary structure is built from advanced carbon composite materials that are not only incredibly lightweight, but also transparent to radar waves. These aren't your typical carbon fiber components though. We're talking about classified materials with properties so advanced that their exact composition remains secret decades after the bomber's first flight. The surface coatings represent another breakthrough entirely. These radar-absorbent materials contain microscopic particles that literally trap electromagnetic energy and convert it to heat. The result is an aircraft surface that swallows radar waves instead of reflecting them back to enemy operators. Maintaining these coatings presents its own challenges. The specialized materials degrade over time and require constant reapplication using techniques that are closely guarded military secrets. Each maintenance cycle can cost millions of dollars and take months to complete. When you combine all these technologies, the result is an aircraft with a radar signature roughly equivalent to that of a small bird. On enemy radar screens, the B2 appears no larger than a pigeon, flying at 50,000 feet. It's an engineering achievement that fundamentally changed the nature of modern warfare. The development costs were astronomical, but the strategic implications were even more significant. Here was an aircraft that could penetrate the most heavily defended airspace on Earth. The B2 Spirit stands as more than just an aircraft. It's a testament to human ingenuity, a physical manifestation of what happens when brilliant minds refuse to accept the impossible. From Jack Northrop's shattered dreams in the 1940s to the revolutionary flying wing that emerged from Cold War necessity, this bomber represents one of the most extraordinary engineering achievements in human history. Every element of the B2, from its radar-absorbing skin to its computer-controlled flight systems, pushes the boundaries of what we thought possible. It's an aircraft that costs more than some nations' entire military budgets, yet delivers capabilities that fundamentally altered the balance of global power. The engineering challenges overcome in creating this invisible giant required breakthroughs in materials science, computer technology, and aerodynamics that continue to influence aircraft design today. As the B2 fleet approaches retirement and gives way to the next generation of stealth technology, we can appreciate what this remarkable machine accomplished. It proved that with enough determination, creativity, and resources, engineers can make the impossible real. The B2 didn't just change warfare. It changed our understanding of what's possible when human ambition meets cutting-edge technology. Sometimes the most incredible engineering achievements are the ones that make us question everything we thought we knew about the laws of physics.